all about the phase of matter, but it's a mixture, a combination of the phase of matter at the same time, physical change, right? Changes of matter. Okay? Like that. So we will be dealing now with phase change. Like this. So klaro kayo guys that we are talking on the phase of matter, which is liquid, okay, solid, and a gas. And then also the changes of matter, right? Which is the physical change. Okay, but in here guys, we're limiting to physical change, not the chemical change. Okay? Physical change, what I am talking. So it's all about, the intrinsic property or intensive property. Ganun siya. Get the point? So what are those? Katong mga melting point, freezing point, ganun-ganun, di ba? Okay? So a whole lot more. Okay? So we need to say independent to the amount of sample and size of the system and the amount of matter present. Something like that. Okay? So don't forget that properties, physical properties. Okay? It's always, very, very familiar. Okay? Like that. So mag-start as let's make a phase diagram. Phase diagram, di ba? Kaloka. So let's say pressure here and temperature here, right? Like this. It's gonna be like this. Ganon. And we have the solid, liquid, and a gas. Okay? Like this. Oh. Now, we will discuss first the ideality of the gas or the ideal gas. So, for example, this is very common, in examination that in ideal gas, what is the operating conditions has been met. Okay, so usually the choices will be basing on the temperature and pressure relationship. So that's why this ideal gas occurs because of this relationship. It's always the pressure and temperature. Okay? Like aside from, as what I remember, considering the compressibility factor of a gas, meaning compressibility or compression ratio, something like that. We need also to deal with the operating parameters, which is the pressure and temperature. So like this. For example, the question will say, if we set an ideal gas, what are the operating conditions between temperature and pressure? A, higher temperature and lower pressure. B, high pressure and high temperature. C, lower pressure and lower temperature. D, none of the above. So you should know that because that's the conditions in which the ideal gas will exist. Or else it will never exist. Sige lang tag-solve, no? Tayo kalibutan. Why ideal gas exists because of that operating conditions has been met. Okay? Aside from the compressibility factor Z is equal to 1. That you can remember, okay, Z, small z is equals to P, pressure, volume, right? If you can remember, the molecular weight, sakto mentionation now, and the RT, universal gas constant. This is one compressibility factor. Two ways, right? If the Z will equal to 1, meaning this is an ideal gas, or nearly equal to 1. You say 4.98, blah blah blah, so and so, 0.999999 like this. As long as the Z will nearly equal to 1. So, the criterion, because it's only 1, the criterion has been met for an ideal gas. If the criteria will be met, so it's pressure, temperature, and the compressibility factor. Okay? Like that. But mostly, what's been asked are the pressure and temperature. Okay? Ganon. So now if we look at this here, okay. Now, if we increase the pressure going up, let's say we start from the solid like this, okay? If we increase the pressure, what will happen to the temperature? Like, tadadak, ganon. Tadadak, 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 tadadak. Ganon. We draw a curve, right? A straight line. And then it will touches across intersection among them. We go in this curve. Ganon. Ganon. So, the solid will turn to liquid, right? Here, the solid will turn to liquid, right? And then here, the liquid will turn to a gas. Here, right? The liquid will turn into a gas. Okay. Now, okay, what is your observation here? Okay, in this dot. Okay, see? Like this. Okay, so from solid to liquid and then to gas. Right? Okay. Now, what did happen to the pressure and the temperature? Ganon. Okay? So, of an ideal gas. Let's consider the ideal gas. Okay? Ganon. Okay? So, did we increase the pressure or we increase the temperature in this case? Okay, let's say we must start as a solid. Okay? Take a look on the graph. Okay? So, in here is very clear, guys, that we increase the temperature from 0 here, right? Here and here. Let's say 0 to 10 and then 5. This is 2.5. Ganon. Okay, and then we have here also 5, 10, and then 2.5. Okay? Ganon. So, muna siyang hitabo. Okay? Kung i-raise the temperature, di ba? Okay, so the pressure will be like that. So this is only hypothetical, but you know, the understanding will be the same. Huh? Because this is not a graphing paper. You know graphing paper? You know, you can create equal on the, you know, axis and the y-axis. X-axis and the y-axis. Ganon. From solid to liquid. So it's gonna be increasing the temperature. Okay. And then lowering the pressure. Okay, that is an ideal gas. Ideal gas. Okay. Low temperature. Oh no, bali siya. High. Diba? Dito ako sa graph. Oh, itaas. So high temperature and then low pressure. Okay, ganun siya. And then Z is equals to 1. So muna na yung i-memorize for me. Okay, that ideal gas will meet the conditions of higher temperature, low pressure, and compressibility factor Z equal to 1. Okay? Muna na siya. Okay. Now, i-erase na to. Now, the non-ideal gas will be the reverse. You will also say, at lower temperature and high pressure, but the compressibility factor Z will either less than 1 or either greater than 1. Okay? Get the point? So that is non-ideal gas. Okay, get the point now. Now, since this is a phase change, let's start as a solid to liquid. Okay, here. Okay. From solid to liquid. Okay? So what process is this? Then the solid will become liquid. Okay. What is the known process for this? So this is melting. The process of melting the solid to liquid. So it will become liquid. The melting point has been reached. Something like that. Okay? Say for example, I get the ice cubes in my refrigerator and I will let that stand or stay for 10 to 15 minutes and it will become a liquid. So the process is very obvious that it's a melting process. Then it will undergo melting point when the solid or the ice change completely to liquid. So from here to here, it will become liquid. Okay. Now it will become liquid. Why? At solid, meaning freezing point, right? Freezing point has been established which is 0 degrees Celsius. Kaya ice man siya. That is the standard and it's 32.2 degrees Fahrenheit, right? Equivalent. Now, solid man siya and it will become liquid. So in here, okay, you increase the heat, right? That's why it will become liquid. Or else it will become more ice if you will, if you cool. You get the point? So if you increase too much the heat from solid to liquid for the melting process, then we can say this is an endothermic environment or endothermic reaction. Let's check by theory before, because maybe we'll be wrong. Okay, let's understand first. Okay, this is the, this is the, ay nako. This is the system, and this is the process. Okay, like that. The process is occurring in the environment. Okay, of course, common sense. The process also is occurring in the surrounding. So meaning to say, the surrounding and environment is just technically equal in definition. Surrounding and environment, in which processes took place there. Our system will be more on the source, input, in which the raw materials are there. Okay, the raw materials, you mix all the raw materials there, or whatever, like that. It's in the source of the system. Let's say you remove the heat from the system. You remove the heat from the system and transfer to the surrounding or to the process. So what type of reaction is this? Exothermic or endo? Okay, so you will understand that if you try to release the heat from, English from, okay, to meaning the point of destination, from is the, the source, like that, okay? So from the system to the process in the environment, so it's gonna be the process become hot. Okay, in which it takes place in the environment and in the surrounding. So in the environment that's already becoming hot, so that is exothermic reaction. Okay, you got the point. So in here, from solid to liquid, this is an exothermic or endothermic. Okay, take note, the ice is starting too much cold because it's freezing. And it will become liquid a little bit, meaning that temperature is rising. Okay, then it gives off the heat. So from solid to liquid, this is exothermic, right? You get the point? Not endothermic. The reverse will be the endothermic when the liquid becomes solid, such as the ice. Okay? So meaning to say, ano na ito pag-istorya? Na if the environment will become cold, that's already endothermic. Never mind with the system, the process. Ano lang para makasabot at diretsyo. May mga chuba. Okay, the environment will become hot, so it will be exothermic. So ang imong reference to consider is the surrounding or the environment. And then the heat will always go in there. Okay? Kaya maglibog magkakagusyon toki on permi ang system. You get the point? Oh, ganon. And then the reverse will be happening. Now, if you release the heat going to the surrounding, and then if you absorb the heat from the surrounding going to the system, you absorb from the system, and then it's become endothermic. Kaya nakadawat man ang surrounding, right? So, inig ka-absorb sa system from the surrounding, that is endothermic also. Get the point? So, nibugnaw na po siya ang surrounding because the heat was being also given to the system. Meaning to say, get the point? So, meaning to say, the system is absorbing the heat coming from the surrounding or the heat from the surrounding to the system. Bali. Ganun siya. Okay? So, dili magdaog sa thermodynamics, sa physical chemistry, ang mga understanding. Because it matters with the sign of the heat of formation, heat content, and the enthalpy of formation. Something like that. The sign will matter a lot. So it means if it's negative, it's it's going to the system or to the system, makalibog siya usahay. Okay? And then, yung mga juktiman ang guess, when the surrounding and environment will become hot, that means exothermic. Okay? Now, how can you denote that the negative sign and the positive sign of the enthalpy? O kani siya, lisod siya, no? O sige lang. Dito sa gas sa solid to liquid, exothermic, and it is melting. And liquid to gas, after this, liquid to gas, the liquid vaporization takes place from liquid to the gas. Okay, liquid to gas, like this. Okay? Now, from liquid to gas, what will be happening here? Did you increase the pressure or did you decrease the temperature? Okay? In ideal gas. So, klaro na kayo sa theory. So, increase ang, na-lower yung pressure. Okay? Kaya mo na siya ang criteria. Okay? Ganon. Na-lower ang pressure sa kanawang graph. So, nahimo na siyang gas from liquid, right? Ganon. Diba? Ganon siya. So, kanina ko lang siya, guys. Two phases involved from solid to liquid and liquid to gas. Ganon. Okay? So, let's erase this one now, ha? Diba? Ako na niya siyang i-erase. Charts. And now, we will notice the different physical changes or the phase changes na. Okay? Ako na niya siyang i-enumerate para din natin maglibog. Okay? Na mag-start dito sa solid to liquid, number 1. Okay? I will just denote S to L. Okay? S to L. Solid to liquid. So this is melting. Okay? Ang technique, guys, the reverse. Ititsuda yun mo para masabtan rin ba? So, to liquid to solid. So, meaning to say, freezing. Right? Freezing or, in another term, it is solidification. Okay? Turning to solid from liquid, right? So, solidification. Okay? Like this. Okay? Like that. And then, dali na yun, freezing point of water is 0 degrees Celsius or 32.2 degrees Fahrenheit. Okay, ganon. So, number 3, ano po ka sa liquid. Liquid to gas, nasa man siya. Actually, guys, this is evaporation, but also vaporization. It's just the same. Okay? Evaporation or vaporization. Okay? Vaporization. Okay? Like that. So, this two matters very, very slight only. When you say vaporization, it talks about the product being released during evaporation, which is the vapor. Sorry, vaporization. And then here talking about process. So, you need to evaporate so that it will become a vapor. So, here is the verb. Here is more on the noun, on the vaporization. The noun here is vapor, okay, and the verb here is evaporate, in the evaporization, but just the same meaning. Very, very slight difference only, okay, but it has the same meaning. Okay, number 4. Okay, gas to liquid, o bali na yung siya, chuga-chuchu. So, unsa man ni siya. So, this is now condensation. You condense the gas to liquid, just like in distillation, right? Okay, you condense gas to liquid. So, mo rin siya ang imong tempasa. Mo rin mo bottom product or overhead product, something like that. You have to understand also. So, after condensation, it will become a liquid or gas in your distillation column, right? There's an equivalent for that, okay? So, condensation. Okay? Like that. Nakakaloka. Okay? Number 5. Unsa pa? So, ang reaction, ang solid changes from to gas. Okay? Solid to gas. Solid to gas. Unsa man ni siya? Solid to gas. So, he's talking about sublimation or sublime. The root word is sublime. The ability of a solid to take place into or to turn into gas. Okay, there are only few. Okay, but one example for that is the mothball, M-O-T-H, mothball. Okay, so this is sublimation. Okay, like that. And then the reverse will be from gas to solid. This is very difficult, from gas to solid because okay, it's very rare that the gas will turn into solid. But there are also situations like that. But it will process first somewhere here from 1 to 5 before it will become to solid. But not directly gas. It's impossible that the gas will directly turn into solid. It will just pass first either from 1 to 5 before it will become a gas. And then solid. Okay? So more or less, it's gonna be the number 4, right? The number 4 and the number 5. Okay, no, it's number 5 only, from solid to gas, because it will become a gas then to solid. Okay? And then, okay, and it will become a solid, so starting from 2. Okay, liquid to solid. Okay, and then solid to gas, and then gas to solid. So that's the time this process will occur. This is deposition. This is not common. Okay, deposition. Okay, like this. Now, in the board examination, you will choose this process to come out because this is not common. Okay, gas to solid. Blank is a process from changing gas to solid. A, sublimation. B, evaporation. So, marok tayo. Ano dito siya sa katang dili common. So, that's our deposition. Or the other term for this is desublimation. Because we have the sublimation, solid to gas, then if you will just reverse, just put D, meaning D removal. Okay? Example, degeneration. So it will not generate. So we need to say desublimation, it will never sublime. So desublimation. Okay, so we need to say deposition or desublimation. Okay? Now this desublimation is not common. Sometimes, always, all the time, deposition is common in the choices, but expected during examination, something like this. Okay, you will not depend the most common terms. Okay, like that. So this is number 6. What else? Okay, muna na siya, no? Okay. So, ang sama sa nag-iingon nila mga guys, fusion. Okay, how do you say it's a fusion? Okay? Heat of fusion. Ay, ganon, di ba? So, kung yung fusion, nahimo siyang liquid. Right? So, from solid to liquid. It's gonna be here from melting, right? Okay, because you will never say heat of melting. You will say heat of fusion, meaning it was fused into something. Tama ka. Okay? So, di ba kung mag-fuse ka mo, melt man siya? Okay? So, okay, wait. So, fusion, the act of fusion. Okay, like this. So, like that. So, when you fuse something, F-U-S-E, English, when you fuse something, so it will become here, here, number 1. Okay? Like that. You get the point? So the heat of fusion, heat of condensation, heat of vaporization, like this, and heat of sublimation. All of them have a heat. And then, sometimes also the heat of vaporization will be called as the latent heat of vaporization. That's also equal. And then the latent heat of condensation is just also equal heat of condensation. You will just add in latent. Di-take ko na siya na term. Okay, but actually it's just the same. Okay? You get the point? But in the books, usually mentioning latent. Latent, chuba-chucho. Okay? You get the point? Okay? So, muna siya mga processes. Okay? You get the point? Diba? So this is 6 phase changes. Okay, class. Any questions so far? Okay, you can like and comment and share this video, and you can subscribe to the channel if you want, and click the notification bell for some news updates. And I am a singer, Eternal Voice. Bye bye, thanks everybody. Ganon. Hala, lalay ng tingog. Diba? Lalay ng tingog, ay. Sige.
The Bluetooth device is ready to pair.
Diba? Okay. Now, let's have the problem solving. Tapos Medyo mahimong adlaw kung wala problem solving, right?